Hi, welcome back to Geometry. We're still working on Chapter 7 and we're going to explore dilations. Our objective in this lesson is to understand dilation images of figures. Dilations are when you have an image and you either enlarge it or reduce it, an enlargement or a reduction. You can use a scale factor, just like we did with similar figures. You can use a scale factor to make a larger or smaller copy of a figure that is also similar to the original figure. So all of the figures that we explore today are going to have corresponding congruent angles and proportional sides because they are similar. In a dilation, the original figure is the pre-image and the resulting figure is the image. So you begin with the pre-image and the dilation, whether it be an enlargement or a reduction, is then known as the image. Prime notation, it looks like an apostrophe, is used to identify image points. So if I had a point A, then if I were to make an image of point A, I would call it A prime. That's what that apostrophe would mean, A prime. A dilation with center of dilation, so in this case the center of dilation is C. And a scale factor we call n. The scale factor, n, is always going to be greater than 0. It can be written as this: dilation with, you would write scale factor here, and then what the center point is. So this is written as dilation with a scale factor of n and a center point c. A dilation is a transformation with the following properties. The image of C is itself. So the center point is the pre-image and the image. So in this picture, C is C prime. C prime is C. For all of the other points, they are on the same ray. So for this example, I have this ray, CR, and this ray goes from the center point to the pre-image. My pre-image here is this triangle PQR. PQR. That's our pre-image. So from C to R is the distance from the center point to the pre-image. Then this one is an example of an enlargement. This ray also contains R prime. R prime is the image of point R. Just like P prime is the image of point P, Q prime is the image of point Q. To find the scale factor, you put the prime, the image, over the pre-image. So you would have a ratio of image over pre-image. So the dilation over the original is how you would find the scale factor. And the scale factor is represented by the letter N. So that's how we represent scale factor. Dilations preserve angle measures. So when you have a dilation, whether it be an enlargement or a reduction, the shape is similar to the pre-image because it has corresponding congruent angles and proportional sides. Let's check out the two types of dilations. A dilation is an enlargement if the scale factor n is greater than 1. To find the scale factor, you would put the ratio of the image over the pre-image. So in this case, we would put the length of CD prime over the length of CD because CD prime is the enlargement, it's the dilation, over the original CD, which is 2. So this scale factor is 4 divided by 2, 4 over 2, it's 2. That's your scale factor. A dilation is a reduction if the scale factor n is between 0 and 1. because the trapezoid FGHE is the pre-image, the original figure, and the dilation of it is smaller, reduced, it's a reduction. You have the length of EH prime, and you would put that over the original figure EH to find the scale factor. So the scale factor would be 2 over 8, which reduces to 1/4. The scale factor is 1/4. Remember, n represents scale factor. So this is an example of a reduction. Finding a scale factor. In the dilation, we want to find the scale factor. We don't know it, but it has a center point of x of this triangle XTR. Is XTR prime an enlargement or a reduction? So the pre-image here is triangle XTR, and the dilation of it is XTR prime. So this is clearly an enlargement. This is clearly an enlargement. In order for us to find the scale factor, we would put a measure of the dilation, so XT prime, over the pre-image XT. Those are the measures that we have. So XT prime is this whole length. So it's 4 and 8. It's the entire length. So it's 12 XT prime. XT is just this piece. So it's 4. So our scale factor is 3. So the dilation is 3 with a center point of x of triangle XTR. What are the coordinates of the vertices of a dilation with a scale factor of 2 of triangle PZG? We're going to find the dilation image knowing the scale factor. So the last example we did, we knew what the image was and we had to find the scale factor. Now we know the scale factor and we're going to find the image. So take a minute and graph the coordinates of the vertex of the pre-image triangle PZG. So here I've graphed triangle PZG. In order for us to find what the dilation's coordinates are going to be, we are going to have to use the scale factor of 2. The center of dilation is the origin, 0, 0, and the scale factor is 2. So the dilation rule here will be, if it's D2, we would take the coordinates of the pre-image points and multiply them both by 2. So let's take the coordinates of P. P is at 2, -1, right? P is at 2, -1. We want to multiply both of those points by the scale factor of 2. So P prime would be located at 4, -2, because 2 times 2 is 4, and 2 times -1 is -2. We're going to take the coordinates of the pre-image of Z, which is -2 and 1, and we're going to multiply them by the scale factor of 2 in order to find where Z prime would be located in this coordinate plane. So 2 times -2 would give us -4, and 2 times 1 is 2. And now finally, we're going to take the coordinates of G, and we're going to multiply them by the scale factor. So G is at 0, -2. So we're going to multiply them by the scale factor of 2 to find where G prime would be. 2 times 0 is 0, and 2 times -2 is -4. Now graph the enlargement of triangle PZG. So P prime is at 4, -2. Z prime is at -4, 2. And G prime would be at 0, -4. So the enlargement of triangle PZG with a scale factor of 2 is like this, and these are the coordinates. Dilations and scale factors help us understand real-world enlargements and reductions, such as images seen through a microscope, on a computer screen, in a photo, or through a magnifying glass. These are some examples. Right? When you take a picture of somebody, if they are 5'6", when you take a photo of them and you're holding a photo in your hand or you have a photo on your phone, it's not 5'6". It's an image of them, a reduction. So let's use scale factor to find a length. A magnifying glass shows you an image of an object that is 7 times the actual size of the object. So the scale factor of the enlargement is 7. This photo here shows an apple seed under a magnifying glass. Its magnified length is 1.75 inches. What's the actual length of the apple seed? Well, just like we did to the points, to find the image of them, we multiplied by the scale factor. So for us to work backwards, if we know the image length, which is the magnified length, is equal to the scale factor times the original, the pre-image, so the actual length. Then we can use the same idea to find the actual length. So in this situation, the image length, the magnified length, is 1.75 inches. And it's equal to the scale factor, which is 7, times the actual length. We don't know. So in order to find it, we would divide the image length by the scale factor. So we would get 0.25 inches. So the apple seed is actually 0.25 inches long. So the actual apple seed is 0.25 inches long. When you put it under a magnifying glass, it magnifies 7 times, so it's 1.75 inches. We'll explore this more tomorrow in class.